Hello and welcome to SudoKanard. We're here to solve this Windoku by British author Jack Lawrence. It was featured in a recent Sudoku Grand Prix. So the special rule of Windoku is that on top of the usual rules of Sudoku, you have those windows, which are extra regions, and it means that those shaded 3x3 squares that are offset with respect to the usual 3x3 squares must contain all digits from 1 to 9. And there's a trick that is very useful with Windoku, which is that whenever you take three columns, like, oops, sorry about that, like those second, third, and fourth column, well, obviously they contain the digits from 1 to 9 exactly 3 times. And if you remove the two windows, then those 9 green cells will contain every digit from 1 to 9 exactly once. And then there is the same with those 9 digits by exactly the same argument. And there is the same with those 9 digits. Oops. And finally, there is the same with those 9 digits. If you take those 3 rows, they contain 3 times the digits from 1 to 9. You subtract those 2 windows, and you're left with those 9 cells which contain the digits from 1 to 9. And if you take all the shaded cells, you have exactly 8 times the digits from 1 to 9. And if you take the whole grid, you have 9 times the digits from 1 to 9. And what remains is the 9 cells, the 9 unshaded cells, which make another extra region containing all digits exactly once. So the interesting part in this is that in this unshaded region, we already have 4 digits, which is the region which is the most constrained at the start. So we know that the remaining 5 digits in here must be 3, 4, 5, 6, and 8. Well, I'm putting a lot of pencil marks, but then something you can see is that this can't be an 8 or a 6 or a 3. So it can't be 6, 8, or 3. This also can't be 6, 8, or 3. So we are left here with a 4, 5 pair. And we can see that the other digits in here can't be 4 or 5. What am I doing? And this one here can't be a 3, and this one here can't be a 3. So that's a 3. And I think that's it for the time being. So we have a 6, 8 pair in those cells and a 4, 5 pair in those cells, which is a nice place to start. Now, where do we look? So we will probably have a look at the digits that appear a lot. So considering those 3s, we know that there is a 3 here or there, but this cell sees this 3 because it's inside this extra region. So we get a 3 in here. And now let's look at this column. So we know there's a 3 somewhere, but because of that, there's a 3 in here. And that's interesting because 3 is then eliminated from the rest of this region and from this cell. So inside this 3x3 block, 3 has to be here, and we get the 3 in here. So do we have all 3s? No, we still need a 3 somewhere in here. Inside this region, so 3 must be somewhere here, but because of this 3, it's eliminated from there. And for this region, the last 3 in the grid is in here. So let's move on to another digit that has a lot of instances. I think 7 is a good candidate. So what about 7? So 7 in this column must be somewhere here, but this cell sees this one through the green region, so 7 can only be here. Now, looking at this 3x3 block, 7 is not in here because of this 7. 7 is not in here because of this 7, and it's not in here. So we have a 7 somewhere here. And now, by the rules of Sudoku, we have a 7 somewhere here. And that's the 7 relative to this region. With those... And now I'm thinking of the pink region. So 7 is nowhere in here, so 7 has to appear in one of those two cells. And I'm saying that, well, 7 is not in here because of this 7 or because of this 7. And so with this 7, we have 7 in one of two places. But considering the yellow region, well, there's nothing more to say, I'm afraid. So perhaps 7 is not the most constrained digit at this point. But what about this extra region? So because of that, we know that 7 is not here. Well, because of this 7, actually. The question could be, on this row, 7 is somewhere in here. It could be here. 7 could be here. I don't think I can do anything more with 7. So let's think about perhaps this area. Or perhaps this column. I'm still missing 3 digits, which are 2, 6, and 9. Well, that's not so interesting, I'm afraid. Oh, but that is interesting on this row. Because of this 2, that's not a 2, but 2 must be somewhere on the row. It's here in the yellow region. But actually, I could have found the same, saying that it can't be anywhere else in the yellow region. So there's a 2 in here. Now 2 is not here. Oh, I don't remember struggling so much during the contest. Perhaps I was more focused. I'm saying that this 1 is not in here, which means that on this row, 1 must be here. So, and I could have found this because 1 doesn't appear anywhere else in the yellow region. So there is a 1 in here. And I'm also seeing with this, there must be a 1 here or there. But that doesn't seem to be so fruitful. Oh, this 5 is more interesting because 5 is not in here in the pink region. So 5 must be somewhere here inside the column. And with this 5, I can place this 5. That is more interesting. So with that and that, there is a 5 here or there. What about this extra region? There is a 5 in here, but because of this 5, 5 is located in here. So no 5 here, no 5 here, no 5 here. So the 5 of this window is somewhere in here. What about this window? 5 is not here, it's not in here, it's not here, so it's here. Nice. What about the green region? It's not in here, it's not in here. Could still be here, here, or here. Well, it's not so promising. All right. Well, where is the next place to look? This column still needs 4, 6, 8, and 9. But 8 is not here in the pink region because of that. So 8 will be here or there. So I was saying 4, 6, 8, 9. So those are from 4, 6, and 9, but that's not a 4 because of this 4. Oh, and now this pink region contains a 269 triple. So that's a 4, and those are 1 and 7. So the extra region property is quite powerful. And in this column, this is from 8 and 9, and in this 269 triple, the 2 is in here, so that's not a 2. Oops. So the 2 in the brown region must be in here, and actually considering this column, those are from 2, 6, and 8. I was saying 2, 6, and 8, but there's a 2 in here. So by the rules of Sudoku, that's not a 2, and that is a 2. And we're here with a 6, 8, 9 triple. So that those digits can't be from 6, 8, and 9. No, I'm saying something wrong there. One of those digits could perfectly be this one. So that was nonsense. On this row, 2 is not in here. It's not here, so it has to be here. It's always difficult to scan those grids, those Windoku, those extra region grids as a general rule. Here I need a 6 somewhere, but because of those 6's, 6 is in here. The other 2 digits are 8 and 9. Now I'm trying to be efficient, which I am definitely not. Well, so where should I look? I think I tend to remember that those pairs here would resolve faster. But anyway, so this row needs 2, 4, 6, and 8. Oh, 6 is not in here. So those are from 2, 4, 8, but there's a 4 here. And that's not a 6. Oh, so that's it, actually. That is a 6 just by the rules of Sudoku. So we get the 1, the 8, and by the extra regions, this here is an 8. So that's a 6, that's a 9. That's an 8, that's a 9, and there's no 9 up there. And this is from 2, 4, 8, but there's already a 2 on the green region, so this is 4 or 8. Those are from 4, 4, 9, 4, 5, 9. Inside this region, so 7 is in here. 6 is not in here, and 6 is not in here because of this 6 in the yellow region, so that is the 6. And now, just by the rules of Sudoku, that is a 6. And that also is a 6. That's the only place on this row where 6 can go. And now with those 6's, I get this 6 and this 2. So some progress is being made. So here I need 4, 7, and 9. 7, so this is from 4, 9. And now on this row I need a 1 and a 7 because of this one. That's a 7, that's a 1. And now that's not a 7, this is a 7. And this is 4 or 9. Here, this extra region needs a 4 and an 8. And I can't believe it, but I can't disambiguate them at this point. 1 on this column can only be here. in this extra region, one can still be here or here. Here I need a 2, a 5, and a 1. So that's a 2. That's a 1-5 pair. Here those are from 2, 4, 8. That's not a 2, so 2 is here. And that's not an 8, so that's a 4. It disambiguates some more. So this 105 is complemented by this one. I need an 8 somewhere on this row, and I don't see where it is. But I see that this column needs a 7 somewhere in here, so that this is not 7. Here I need a 1, and it's not here, so it's here. Those are 8 and 9. So 8, 9, that's a 4, that's an 8, and it resolves some more. Here I need 8 and 9, there's an 8 on this row. And there was a 9 in the yellow region. So this is 2 and 7, there's a 2 here. So we're slowly getting there, that's the 7. That's a 1, so that's a 5, and this here is an 8. That's a 5. Oh, finally the 5 and the 4 in the pair are resolved. 5, 1, and finally the 9 up there. Oh, what have I done? Oh, I've made some misplaced. Don't know what I did with that. Well, anyway, this finishes this solve, which was a bit of a struggle. Well, fortunately, I think I was a bit quicker during the contest, but it's still a very well put puzzle. But you need to know the theory, you need to know the trick to stand a chance against this kind of tricky puzzle. Thanks for watching this video, and see you soon on SudoKanard.